In the previous video, I demonstrated a rate governance use case using the new Smartsheet MCP on Claude, and also a more structured MCP approach built using Make.com. To summarize the findings, Smartsheet MCP is incredibly flexible and powerful for exploratory AI interactions, quick proof of concepts, and just getting value quickly with very minimal setup. There are also scenarios where organizations may want more targeted access to their operational assets, more repeatable execution, and clearer governance and control. For processes requiring this kind of structure, this is where platforms like Make.com becomes very compelling. Now here's a sneak peek of what it's capable of. The agent starts by identifying the right project. It then retrieves the rate items, and then it searches the email context to match it against the rate items. Finally, it provides the evidence and recommendation in a concise format, and before making any changes, it asks for permission. Once that permission is given, it updates the rate log and confirms that the update is done. Let me walk you through the system architecture of the Make MCP server. Instead of allowing AI to dynamically search broadly across the entire environment, we can define the capabilities available to AI, the systems that it can interact with, and the exact boundaries the AI should operate in. At a high level, AI is still acting as the reasoning engine, interpreting the user's requests, and dynamically selecting the appropriate operational capabilities. We can then apply system instructions so that the agentic process behaves consistently, follows operational rules, and returns structured output. In this example request here, where the user is asking the system to search for emails and advise if any rate items can be closed, it selects only the capabilities that are relevant. In this case, they are retrieve rate items, search email contacts, and update rate log. Each capability has been configured carefully to ensure that it only searches the Smartsheet assets that are relevant to the requests, while other irrelevant or sensitive assets remain inaccessible. This creates a much more structured and governed operational AI approach, and one that is reliable and consistent. So now let's have a look and see how this is built in Make.com. First, I'm going to start by creating a MCP toolbox in Make by clicking over here, and I'm going to create a new toolbox. Now, the purpose of the toolbox is that it will allow us to define the capabilities that the AI will be able to use. So I'm just going to give it a test name called project summary query, and I'm going to go ahead and create the toolbox. Now, when you create it, make sure that you copy and store the key somewhere secure, as we'll need it later when connecting the toolbox to an external AI system. Inside this MCP toolbox, we'll define which make scenarios can be used as tools, and I will show you how that works shortly. Now, the most important point is that this toolbox can be exposed as an MCP server. That means a user can interact from an external AI tool such as Claude, ChatGPT, Gemini, or Copilot, while Make still carries out the orchestration work in the background. Now for today's walkthrough, I'll use Claude as an example LLM client because the setup is straightforward to demonstrate. But the main focus of this video should still be on the Make side, and that includes how we define the tools, how we control the scenarios, and structure what the AI is allowed to do. If you're using another platform, the front-end setup will look slightly different. For Copilot users, you would typically use a Copilot Studio agent, while ChatGPT users would have to create an MCP app and add it to a custom GPT. And finally, for Gemini users, you would use a custom agent and a MCP server data store. I've linked 3 separate setup guides for those below. Once that connection is in place, the principle is the same. The user chats in their AI tool of choice, and Make controls the backend tools, scenarios, and execution. Now let's head over to Claude, where I am going to create a project. For the name, I'm just going to give it a simple name like project summary query, and give it a light description on what it's going to do. So I'm going to say reads and updates the project summary sheet, just to give some context to the AI model. I'm going to create a project, and now the first thing that I'm going to do is to connect this project to the Make MCP server. And to do that, I'm going to click on this plus icon over here. I am going to go to connectors, add connector, and add a custom connector. So as before, I'm just going to give it a simple name. And for the remote MCP server URL, it goes by the following convention. As you can see over here, this URL convention is not specific to Claude, and it also applies to other LLMs. So now all we got to do is replace these fields with the ones that are in the project, the MCP toolbox that we created earlier. So the MCP toolbox URL, you can find that over here on the left-hand side by copying the MCP server URL. So we're just going to replace this field altogether. Now that we have the URL nicely over there, we will keep the /t/convention. And now we're going to replace the toolbox key. So as you can remember earlier, when we first created the MCP toolbox, we copied over the key and stored it in a secure place. So now I'm just going to grab it and then just fill it in. So as you can see over here, this is our key pasted inside. And for the transport method, it's recommended by Make to go stateless. And this is recommended due to its connections reliability. So now that we have the MCP URL over here nicely completed, I am going to leave the two optional fields blank over here, and I'm just going to click Add to set up the connection. And as you can see here, it nicely reads the URL and is now asking us permission to connect to our Make account. So I am going to allow it to run my scenarios. And because for the purpose of this demo, I only want it to be able to run my scenarios, nothing else. I'm just only going to allow this one permission. So with that being said, I'm going to click allow. Oh, but before that, let us first select the organization, and then we're going to click allow. Now we're all set. So right now, this project is currently linked to Make, and it will now have access to all the capabilities that we will add on later. Now, just for completeness sake, I am also going to paste some instructions over here in general, just to give the agent a little bit more context as to what it is supposed to do. So I'm going to save the instructions here, and voila, we have it now all set up. So now that we have connected our LLM to the MCP toolbox in Make, it's time to actually give it capabilities that it can call depending on the user's request. And capabilities come in the form of tools in Make. So tools consist of either scenarios or modules, but now I'm going to give AI the ability to retrieve information from my project summary sheet. So with that, I am going to add a module, and I am going to search for the Smartsheet app. And in order to retrieve information from a sheet, I am going to find the get a sheet module. I'm going to give it a simple name like retrieve project summary. And to accompany that, I am also going to give it a short description. Now, this description is crucial because it serves as a hint for AI on when to call for this tool. Now for the connection, I'm going to select our demo connection, and for the sheet ID, I am now going to specify the exact sheet that it's able to look at and to retrieve the information that I want. Now that we have selected this sheet ID, the AI only has access to the sheet and nothing else. And this is quite a contrast from the Smartsheet out-of-the-box MCP solution, which I demoed in my very first video, where if you give it the permission to read sheets, it will be able to broadly read every single sheet within the workspace. Whereas in this case on make.com, we are able to specify a more targeted access when prompting the AI. So I'm going to click Add, and I'm going to save it. So now our toolbox will now have a single tool. And to complement this read action over here, I am going to add another module that will allow it to update the project summary based on the user's request. So as before, I'm going to create a module, and again, it's going to be Smartsheet. And instead of getting a sheet, I am going to use the update a cell or update cells module. And again, I'm going to give it a simple name, update project summary, and also a short description to complement it. Right. So now I'm going to select the same connection as before. And for the sheet, like before again, I am going to select the project summary sheet so that it can only update information in this sheet, nothing else. Right, so for the row ID and the cells, I am just going to let the AI decide which rows and cells to update, because this will be dynamic depending on the request of the user. So now that's done, I'm going to click Add, I'm going to save it. Now we're going to test it. I am going to ask it to fetch me the projects under the construction governance program and tell me what the priority is. To retrieve project information, it calls the retrieve project summary capability. It then nicely lays out the summary of the project. And now to test the write capability, I'm going to ask it to change the priority to high. It asks for permission before executing it. And once that's confirmed, it calls the update project summary tool and applies those changes to the sheet. So what we've just built here is a simple version of a MCP server in Make. We've shown that Make can expose a control tool that can read from Smartsheet and write back to Smartsheet, and that we can also test it directly from the chat interface. Now, this proves that the core setup in Make is actually quite straightforward. Now, I'm not going to build every tool and scenario from scratch in this video because the fundamentals are the same. We've already covered the core setup, which included exposing the MCP toolbox to the LLM, adding the system prompt, and creating a simple control read and write tool in Make. So from here, I'll switch to the completed version of the build, where this agent has the full sets of capabilities needed for the rate governance example that I demoed to you at the very start of the video. The first thing that I want to highlight is the completeness of the system instructions over here. Let's break down the system prompt. First, we define tool and scenario limits, and this keeps the AI bounded within the access that it has been given. Second, we require permission before changes are made, so users stay in control of all the Smartsheet actions. Third, we require evidence-based updates. And fourth, we prevent verification of information so that AI does not invent any information where evidence is not available. And finally, we define structured output, so responses are consistent and thorough, yet concise. So collectively, these instructions define the operational boundaries, governance rules, and behavior expectations for the MCP server. Now back on the capabilities of this MCP toolbox. This includes tools like retrieving the rate item, searching email for contacts, and even updating the rate log through a controlled make scenario. And for more complex processes, such as updating the rate log, this tool is represented by a scenario. So let's head in and see how this scenario was built. This is represented by a series of execution steps, 4 modules in total, each with its own function. It starts by identifying the correct project folder, and this is done by querying the project ID. It then searches for the rate sheet of the project in the very same folder. It retrieves information on the rate item to be updated, and then it updates the row on Smartsheet with all the new information. Now, this creates a much more structured and governed approach where AI performs reasoning by giving inputs to this very scenario of the system. And based on the user requests, the scenario controls how the actions are executed and which assets can be accessed. Now, onto the section of the video that you're most looking forward to. I am going to show you the full capability of this rate governance agent built on make.com. So I am going to give it some instructions. So I'm asking it to search for my emails and tell me if any of the rate items in Project Build Smart can be closed. And notice how I'm just giving it all the instructions at once, and rather than guiding it through a series of prompts. So let's see how this rate governance agent built on Make MCP fares in general. The agent starts by identifying the right project. It then retrieves the rate items, and then it searches the email context to match it against the rate items. Finally, it provides the evidence and recommendation in a concise format, and before making any changes, it asks for permission. Once that permission is given, it updates the rate log and confirms that the update is done. So, what we've just seen here is not simply an AI chatbot answering a question. The agent searched across email, identified the correct project, retrieved the relevant rate items, assessed the evidence, made a recommendation, and asked for permission, and then updated the Smartsheet through a controlled process. This combination of system instructions, targeted access, controlled execution, and human approval is what turns this from a chatbot into a governed operational AI process. And that controlled process is the key point. It's not just whether AI can access Smartsheet, it's what data it receives and how the action is executed. A good example is large Smartsheet sheets. And one practical point is that you don't always want to pass the entire Smartsheet into AI because large sheets contain many columns, fields, and metadata that may not be relevant to the request. Passing all of that into AI uses more context and makes the response less focused. But with Make, we can shape the data before it reaches the AI, removing any unnecessary data and only passing the information needed for the task. And that makes AI more reliable. This is exactly the kind of design work that we help clients with, not just connecting AI to Smartsheet, but structuring the data, access, prompts, and workflows properly for operational use. And if you're experiencing problems around large data sets or exploring something similar, feel free to reach out. Although today we've focused on Smartsheet and emails, the bigger opportunity goes much further than this example. The same pattern could extend to meeting transcripts, where AI could identify follow-up actions and update the rate log automatically. It could also connect to time management systems to help update time entries based on what happened in those meetings. But the wider point is that this pattern is not just limited to project management. The same approach could support any process where teams need to connect context across multiple systems before deciding the next action. So the real value here is not just updating a rate item. It is connecting business systems together so AI can retrieve context and reason across multiple sources and then support the next action. My name is Alvin from Blue Precision Technologies. We help organizations design and build AI-powered workflows that connect tools like Smartsheet and Make, as well as LLMs in a structured, governed way. If you're exploring a similar use case, fill in the form linked below and we will be in touch. Thank you for watching the final part of this three-part series where I covered Smartsheet MCP and utilizing AI with Smartsheet in general. So if you haven't already, please check out the first two videos where I compared Claude MCP and the Make MCP setup, and also a separate video showing you a tutorial on how to set up Smartsheet MCP in Claude. Thank you all for watching and I'll catch you in the next one. Bye.